Let's take a look at the effect of k on the sinusoidal graphs of sine and cos. So we know that k is going to affect a horizontal stretch or a horizontal compression of our graph. So we know that therefore it's going to affect the period of the graph. And we know that generally for sine and cos, a sine and cos curve that has not been transformed, its period is 360. And so a horizontal stretch or compression, which is k, is going to directly affect the period. So we know from working with k and other functions, if the absolute value of k is greater than 1, then the graph is going to be horizontally compressed. And if k, the absolute value of k is less than 1, then we know that the graph is going to be horizontally stretched. So we don't need this little part here. And if we know that k is less than 0, so it's negative, then the graph is going to be reflected on the y-axis. So we can apply k in the same way that we've used it in other functions by dividing all of our x values by k, or by multiplying it by 1 over k. Or we can look at its direct effect on the period, and the period of each function is going to be 360 divided by the absolute value of k. The reason why that works, normally we would be dividing all of our x values by k, and so therefore we would take our period and also divide it by k in order to find our new period. Let's start with this example here. So we're going to graph 2 cycles of the function y equals sine of 2x. So let's fill out our amplitude and period first, and then we're going to go ahead and graph it. So in this case, our amplitude is 1, since our a value is 1. So our amplitude is equal to 1. And our period is going to equal 360 divided by k. So it's going to equal 360 divided by whatever our k is, which is 2. Therefore, our period is going to be 180 degrees. So if we have to graph 2 cycles of this, that means 1 cycle is going to be 180 and 2 cycles is going to be 360. So that's the maximum that we need to get to on our x-axis. So we have enough squares then to make each square 15 degrees, or every 2 squares 30 degrees. So let's go ahead and add that scale now. On our y-axis, we're not shifting left or right, so we can make our y-axis right along this boundary of the graph here. And since our amplitude is 1 and we're not shifting up or down 1, the maximum value of this graph is 1. So let's put our maximum at 1 and our minimum at -1. And now we're ready to graph. So just like before, let's start off by graphing the first and last values, then the middle values, and the 2 quarter marks. So starting with 1 cycle, because this is sine, we know that sine of 0 is 0. Therefore, we're going to put a dot at the point 0, 0. And we know that sine is going to come up and come down and come back again. So this cycle is going to end at 0, but it's going to end at 180 degrees because our period is 180 degrees. So we're going to put a dot at 180. That's going to be the end of our curve. And again, since we know sine comes up and then crosses in the middle, comes back, the middle of 0 and 180 is 90, so we can put a dot at 90. And now we're ready for our quarter marks. In the middle of 0 and 90, it's going to hit its maximum value, which in this case is 1. So the middle of 0 and 90 is going to be 45, which is going to be exactly in between 30 and 60. So we're going to put a dot at 45. And then we also know it's going to hit its minimum value in between 90 and 180, which is going to be at 135. So we're going to put a dot at 135 and -1. And we're ready to connect the dots. So we're going to connect it with a smooth curve, and then we're going to do the same thing for our second cycle. So continue the pattern yourself and continue to draw a second cycle. Okay, so check to make sure that your graph ends at 360. So the second cycle should go between 180 and 360. It's also going to hit the x-axis again right in the middle of those two, which is at 270. And in the middle of 180 and 270 is going to hit its max value of 1, and the middle of 270 and 360 is going to hit its min value of -1. So now we can add in our domain and range. Just of these 2 cycles, x is an element of R, but we know that x has to stay in between 0 and 360, and that's 2 cycles. And our range has not changed. So our range, y is an element of R, such that the highest value is 1 and the smallest value is -1. So y is the same between 1 and -1. So what was affected this time by changing our k value was our period and also our domain. Because normally, if this was 2 cycles, it would go all the way to 720. Let's try another example. So let's take a look at the graph of y equals cos half of x. So here's our k value. So our amplitude is still equal to 1 since our a value is 1. Our period is again 360 divided by our k value, which is a half, which is going to be like multiplying 360 by 2. So our period is now 720 degrees. So it's going to double. So this thing is going to get horizontally stretched, which we know is going to happen when k is less than 1. So now go ahead and add a scale to make sure that the highest x value that we get to is 720, because we're just drawing one cycle of this. And we know that we only need to reach an amplitude of 1, and we're not shifting up or down. So therefore our max is 1 and our min is -1. So go ahead and draw your scale now. So maybe your scale is different than mine. As long as you get a maximum value of 720, or as long as you get to that 720, that's fine. So I decided to count 4 squares as 90 degrees to get to that 720. I made my value of 1 equivalent to 6 squares on the y-axis, and -1 is also 6 squares. And now we're ready to graph. So just like before, we're going to start with our first value and our last value. So we know now we're dealing with cos, which means cos of 0 is not going to be 0. It's actually going to be 1. So because our amplitude is equal to 1, we know that the highest value is 1. And we know that cos is going to look sort of like a bowl, so it's going to come down, come back up. Instead of ending at 360 now, it's going to end at 720 because one cycle is 720 degrees. So we're going to do our final value at 720 and 1. Now we know that the minimum value is going to happen in between 0 and its end value, its our ending value, which is 720. So in between 0 and 720 is going to be 360. So at 360 is going to hit its minimum value of -1. In between, so the quarter marks, in between our first value and our middle value, it's going to cross the x-axis. And in between 0 and 360 is 180. So it's going to cross the axis at 180. And in between 360 and 720 is 540. So it's going to cross the x-axis again at 540. And now that we have this done, we can go ahead and connect them into a cos curve. So it's going to look something like this. So just to triple check, we should have a curve with amplitude of 1, which is exactly true. And our period is 720. So one cycle 720 degrees. We can go ahead and add our domain now. So our domain, we know that x is an element of R, but we know that for the cycle that we drew, 0 is less than or equal to x is less than or equal to 720 degrees. And for the range, our maximum and minimum value have not changed. So we have our range, y has to stay in between 1 and -1. So now let's look at an example where we're going to change our a value and our k value. So if our a value is 3, then we know our amplitude is also equal to 3. So let's add that into our chart. So we know our amplitude is equal to 3. And we know our period is going to equal 360 divided by our k value. And our k value is also equal to 3. So here's our k value. And here's our a value, just as a reminder. So 360 divided by 3 is 120. So now our period is 120. And we've got to get through 2 complete cycles, which means that the maximum value we need to get to is 240. So on our x-axis, we can make it work so that every 4 squares is 30 degrees, and we'll be able to get to 240. So go ahead and try that now. In terms of our y-axis, since we're not shifting to the left, we can make our y-axis right at the corner here. And we know our amplitude is 3, which means that the highest value we need to get to is 3. And we're not shifting up or down. So why don't we make every 2 squares 1 unit so we can get to that 3. So therefore, on our negative y-axis, it will look something like this. So now we're ready to graph. We have to graph a sine curve that has an amplitude of 3 and a period of 120. So let's start with one period to start. So we know sine, it looks like the S. We know it has to start at the point 0, 0, so let's add that in first. And we know it's going to end on the x-axis, and the end of this curve should be at 120 because one cycle is now 120 degrees. So we're going to put a final dot at that 120. In the middle, as per usual, is going to cross the x-axis again, and in between 0 and 120 is going to be 60 degrees. So we're going to put a dot at 60. And then in between 0 and 60, that's where it's going to reach its highest value. So in between 0 and 60 is going to be 30 degrees. And its highest value is no longer going to be at 1. It's going to be at 3. So we're going to put a dot at 3. And then it's going to reach its lowest value in between 60 and 120. And at that value, it's 90. So at 90 degrees, it's going to hit a minimum value of -3 since the amplitude is 3. So let's go ahead and connect them into a continuous curve. And let's go ahead and graph one more cycle. So try the last cycle on your own. So your last cycle should look something like this. And now we're ready for our domain and range. So in this case, our domain, x is an element of R, 2 cycles of this graph. In our graph, we started at 0 and we're going to end at 240 degrees. And for our range, because our amplitude is now 3, our maximum value is 3, and our minimum value is -3. So now we're ready to put everything together. So we know how to work with D and C. We know D is just our horizontal shift, which we can call the phase shift. C, as per usual, is just our vertical shift, which we can also call the vertical displacement. And A will be our amplitude. In our equation here, we're missing K, so let's add K in. So we have a K value here and a K value here. So we know that we can graph K by looking at its direct relationship with the period, and we know that the period is going to be 360 divided by the absolute value of K. So when we are graphing all of these transformations together, the easiest way to graph them is to draw our amplitude and period first, then do our reflections, whether it's in the x or the y axis, and then shift vertically or horizontally. If you're able to do the amplitude, period, and reflection all at the same time, that's awesome. But if you need to break it up into 2 steps, go for it. Alright, so let's try 2 examples where we put them all together. So taking a look at our equation here, we have negative cos 2x minus 180 and 2 plus 2. So let's go ahead and add some letters. So we know our a value is just here, it's going to be -1. Here's our k value, that's our 2. Then we have our d value, and then we have our c value. So let's help plan out our graph by filling out the chart below. So we know our amplitude is, our a value is -1. So our a value is -1, but the amplitude is going to be the absolute value of that, which is still 1. So that means that our amplitude is still equal to 1, but there's going to be a reflection in the x-axis, or yeah, in the x-axis. So let's just write ourselves a note that we have to reflect in the x-axis. Taking a look at our period, we know our period is affected by our k value. So our k value is 2, so our period is 360, but we're going to divide that by our k value, which is 2, and we're going to be left with a period of 180. So this is going to be horizontally compressed. Taking a look at our d value, our d is equal to 180, which means that we are going to shift to the left, sorry, to the right, 180 degrees, and our c value is 2, which means that we're going to move everything up 2. So if we're going to plan out our range here, let's take a look at, or let's plan out our x values first. So we know that it has a period of 180 degrees, but we're shifting to the right 180. So here's the information that we need. We know that one cycle is 180 degrees. We also know we have to graph 2 complete cycles of this. So normally our maximum, so our max value would be 180, times 2 because we're doing 2 cycles, so 360. But we're going to move it right another 180, which means that we've got to take 360 and add another 180. Which means the max value we need to get to on our x-axis is 540 degrees. Now let's take a look at our range. So our range, since the amplitude is 1, normally the max is 1 and the min is -1. But we're also shifting up 2. So that means that our max value is going from 1 up 2. So it's going to be 3. So when making our scale, we need to make sure that we get to a maximum x value of 540, and we need to get to a maximum y value of 3. So create a scale where you can do that, and then check back in the video and make sure you've got an accurate scale. So you don't have to have used the same scale as me, but what I decided to do is I decided to make every 4 squares equal to 90. And by doing that, I can get all the way to 540. Also make sure that you can get to a maximum of 3 on our y value. And now we're ready to graph. So let's first start by graphing our amplitude and our period. Then we're going to go ahead and do reflections, and then we'll shift it right and up, just like the list above says. So start with one cycle first, and then you can duplicate it for the second cycle. So I'm going to use 3 different colors to graph this. So first let's do a graph that represents an accurate amplitude and period. So our amplitude has to be 1 and our period has to be 180 degrees. So because this is a cos curve, we know it's going to start at 1. Let's make this bigger. So we know at 0, the value of our curve is going to be 1. And we know because it has to end at 180 degrees, at 180 degrees, the value also has to be 1. In between 0 and 180, that's where it's going to hit its lowest value of -1, and that's going to happen at 90. So we're going to put a big dot at 90. And then the quarter mark in between 0 and 90, that's going to be 45. That's where it's going to hit the x-axis and hit the x-axis in between. Again, so if we connect these, we have this cos curve that looks something like this. So let's go ahead and duplicate it for the second cycle. So try that on your own. So the second cycle is going to have the exact same properties. It's going to start at 180 and end at 360. So our first step of graphing our amplitude and our period is done. So our next step is to graph any reflections. So we do have a reflection, and it's in the x-axis. So let's go ahead and we're going to flip all of these points into the x-axis. So this 1 up here is going to become -1 and etc. So once we have all of our points reflected in the x-axis, we can connect them with a continuous curve like this. Okay, so step 1 is done. We have the amplitude and period. Step 2, we have a reflection. Our last step is to do our translations. And we know we have a translation to the right 180 and up 2. So all of these blue points here are going to get shifted to the right 180 degrees and up 2. Make sure you take that you take a look at your scale. So right 180 degrees. We've made 4 squares 90 degrees, which means 180 degrees is moving it 8 squares to the right, and we've got to move it up 2, but up 2 units doesn't mean 2 squares. We decide to make 1 unit 2 squares, therefore up 2 units means we got to move it up 4 squares. So let's try it with this first guy here, and then you can try the rest on your own. So I'm going to use green. So I'm going to move this guy 180 degrees to the right. So 360 plus 180 is going to be 540. And then we got to move it up 2 units, and each unit is 2 squares. So we're going to move it up 1 and then up 2, and our final point is going to be right here at 540 and 1. So let's continue that for all the rest of the blue points. Once you've moved every single point to the right 180 and up 2, you should have a graph that looks something like this. Its beginning value should be at 180 and 1, and its ending value should be at 540 and 1. So let's label these very quickly, or I'm going to label them in black. Okay, so this red graph here, that was our graph that had only the correct amplitude and period, which means this is the graph of y equals cos of 2x. That's an amplitude of 1 and a k value of 2. Then we had our red graph. That's after we reflected in the x-axis, which means this is the graph of y equals negative cos of 2x. So it's not the complete graph, but here's our final one. This is our graph that had all of the transformations. Had the reflection, it had the horizontal compression. So we have our 2, and it had our shift. So x minus 180 and then plus 2. So let's quickly add in our domain and range. So try that on your own and then check back in. So our domain, how we graphed it, our minimum value is 180 and our max is 540. And in terms of our y has to stay in between the values of 1 and 3. So let's try this last example together, and then you'll try your final example on your own. So we have this equation here. So here's our a value, our k value, our c value, our d value, and our c value. So just labeling that really fast. We have a and k and d and c. So let's fill in our table as much as we can. So we know our amplitude is going to be our a value, which is -2, and just the absolute value of that. So our amplitude is going to be 2. Our period is 360 divided by our k value, which is a half. So 360 divided by a half, that's just 720 degrees. So we also have some more transformations going on. We have this negative here, which means that we are going to have a reflection in the x-axis and axis. Okay, and then our d value is 60, which means we're going to move it to the right 60. So right 60 degrees. And we're going down 1 unit. So that's because our c value is -1. So planning this out, we know that in terms of our domain, because we're only graphing one cycle and our period is 720, the maximum x value we should have had is 720. But because we're moving to the right 60, we got to add 60 degrees to that, which means our max is actually going to be 780 degrees. If we take a look at our range in terms of our maximum or minimum value, because we're moving down 1, it's going to affect our minimum value. So our minimum value is normally going to be -2. The reason is because our amplitude's 2. And we're going to go down 1. So we got to subtract 1 from that, and our new minimum is -3. So we need to make sure that whatever scale we make, we hit a maximum of 780 on our x and a minimum of -3 on our y. So why don't we try to go up by 60 degrees every 2 squares? So every square is worth 30 degrees on our x-axis. And on our y-axis, we know we have to hit a minimum of -3. So it makes sense if we make each 2 squares 1 unit. So we've got 1, 2, 3, -1, -2, -3. So finish off that x-axis. Alright, so now that we've got our x-axis plan, we've decided to go every 2 squares is 60. This is going to be nice and easy to shift it over 60. So let's go ahead and start graphing our one cycle. So we know that because this is sine, we know it has to start at the point 0, 0. So we're going to start off with that. If we know that this one cycle is 720 degrees, we know it has to also end at 720. So here's our ending value right over here. Sine is going to come up and cross in the middle and come back up, go down and then come back up. So in the middle of 0 and 720 is going to be 360. So let's put a big dot at 360. And now from our maximum value, that's going to happen in between at the quarter mark, between 0 and 360. And in between that is 180. So at 180, it's going to hit a maximum of 2 because our amplitude is 2. And in between 360 and 720, that's going to be 540. And that's where it's going to hit its minimum value, which is -2. So we're going to plot at -2. So let's connect that with a curve. Here we go. All right. So now that we have the amplitude graphed and the period graphed, now let's work on our reflection. So we've got A and K done, but we haven't dealt with the negative in front of A. So we're going to reflect all of these points in the x-axis. Once we've got all our points reflected, we can connect them with a smooth curve. And we've finished step 2. So our step 2 is making sure we've finished our reflections, which we have. So now we've dealt with A and we've dealt with K, and now we're just ready for the shifts. So we're going to shift every one of our blue points to the right 60 and down 1. So we've made 60 degrees 2 squares. So we're going to bring every single point right 2 squares and down 1 unit. And we made 1 unit 2 squares as well. So we're going right 2 and down 2. So let's go ahead and do that. So we're going to take our first point right 2 and down 2. So we're going to have a big dot here. Let's make that bigger so you can see it here. Our next point, right 2 and down 2, is going to be here, and continue that on your own. So once you've done your shifts and you've connected your dots, you're going to have a graph that looks something like this guy. So I've gone in and added some labels. So this is our final graph that had all of our transformations, which is why we've copied down all the transformations here. Our red graph here was our first graph where we just graphed the amplitude and the period. So we have our 2 for A and our K value is a half. And then our blue graph is after we reflected it. So it's the same equation but a negative in front of it. So now let's add in our domain and range. So that's of our final our final transform graph. So here's our final transform graph here. We know our domain has to be between 60 and 780 degrees. So let's quickly add in our domain. So we know that x is an element of R such that it has to, or how we graphed it, has to be between 60 degrees and 780 degrees. And our range, the maximum value is 1 and our minimum value is -3, which we predicted. So our range is y is an element of R such that the minimum value is -3, so it's going to bounce in between -3 and 1. So for our final example, try this completely on your own and check back in the video for a final solution. Before you go though, make sure that the trick with this guy here is to make sure you factored this out. So make sure you've rewritten this as y is equal to 0.5 sine, and then factor out that 2 so that we know the true value of our d. So we're going to be left with x minus 30 degrees minus 1. And so we know that this guy is going to have an amplitude of 0.5. Our 2 is going to affect our period, so our period is going to be 180. We're going to shift to the right 30 degrees and down 1.